let's talk about STL. So, are you ready? Is that good? Okay, cool. So one of my backgrounds is, so I was in AAA games, and then I went to MathWorks and brought a bunch of game developers to MathWorks. We went to science, and it was really cool because we're able to bring efficiency and speed, and in games you have to do a lot of design patterns, and it's pretty hardcore. So I've seen a lot of performance mistakes in legacy code and in real-time code, and I'm just going to kind of go over some of the things that we can do every day. So this isn't really like, here's this high-level optimization to do, which is how we know all optimization really should be. But there are things you can do every day in your coding to make sure your code is fast and you don't die by 1,000 cuts. So again, games is a very performant industry. If you guys are looking for really good C++ game developers, like go and check out games, go recruit people from games, because the industry changes so much. So you can find some super good devs there. So an example, MathWorks, we had a graphical thing, and moving a block across the screen took a millisecond. The guy's like, this is really good. It only takes a millisecond. Like, a millisecond in games is an eternity. Like, oh my gosh, now you move 1,000 blocks in a game, the application freezes for a second. So like you have a lot of real time is a totally different mentality. So every line of code really does matter. So common mistakes I see, obviously, copying objects. There's a lot of things like, this is a small object now, it doesn't matter, or this is a shared pointer, I can just copy instead of pass by reference. Like do the easy stuff. Pass by reference. Don't have any extra work done unless it actually gives you benefit. And I find more often than not, people kind of just feel like, oh, in today's age, I don't need to. Obviously, choosing the wrong data structure, we all know that from like CS 101, that you need to make one that matches. Like if you're going to iterate over something a lot, don't pick something that has memory scattered all over the place. Don't have a map or something like that. You need memory that's next to each other. A big one I found, especially in legacy code bases, is doing duplicate work. Right? I look up a variable, and then I look it up, and I look it up, and I look it up, and it's the same one over and over and over. And like maybe they do it in 3 different functions. Maybe the functions are spread out, but maybe they're called from like the same type of area. Like there's a lot of duplicate work that can happen in a code that we can avoid. That makes a big difference. And Optimizer does well. I remember interviewing someone for an optimization position, and every answer was like, well, the optimizer does that. Like, well, how do you make this faster? Well, the optimizer takes care of it. Like, the optimizer isn't like this miracle worker, right? They do some really cool stuff, but they don't solve everything. Like, we can do a lot. So a simple thing on vectors, STL vectors, like vectors, like almost always the best choice. Not saying I need a map, right? There's times where you need a map, but like vector, you can do some tricks to make it act sort of like a list when you need a list. One of them is something I use a lot, which is how to race from the middle. So like, you don't want to like, I have a million items, I'm gonna race in the middle, I'm gonna grab those things and I'm gonna move them together again. Like, we don't want to do that, right? If it's unordered, you can do something really simple, which is just to copy the last item onto where you're deleting it and then pop back, right? You don't have any reallocation, it's really quick. So I put a bunch of these types of template functions in there, so I can just say, hey, I want to race, I want to do a fast race or not. And the other one I put, like if you're gonna lock a mutex and do some like a copy of a vector, just do a swap. Like have a dummy vector and just swap them, right? You don't need to do a full deep copy and keep the mutex locked. Now, one really big thing for legacy code, so MathWorks, 100 million lines of code, things like that, was in maps, they have things that they would look up the same item millions and millions of times, and the data would never change, and the answer was always the same one they were looking up. So, I built an STD map that would track that usage. So it just simply produced stats. So like, let's just find the ones that produce the problems. And then, then I can replace it with a last recently used map. So then a little tiny cache which just says, hey, if nothing's changed in the map, I just keep the last thing you looked up and the last key you used. And if they're the same, then I don't even have to do a search. So it's like, it's not really it doesn't make sense for things that are volatile or things that you're searching to all these other different things all the time, which is why you need to kind of do the statistics to see if it works. But if it does, it's a huge boost to it's almost like a freebie, right? Because you can be in the middle of a system. One of the arguments was like, we're a scripting engine, so who knows what data we're going to have? Like, everything has a pattern. So a lot of people don't make assumptions that just because it's kind of random things that you think that it will never have a type of pattern. Do the research. And then this is a really fun thing. Everybody's got that one thing they wrote that they love. Copy and write template. I can't really talk too much about it except for because it's so long. But when people don't want to return by reference, I have a million item object. And I don't want to return by reference because the state might be gone. like this copy and write template was great because I can return this. It does a atomic reference counting, and the moment someone needs a writable version, it forks. So that way, it's like a really great way to go into a legacy code base and start improving it without having to understand all the state and everything. So I'm like, hey, if it changes, great, then you got your copy. If it doesn't, it's a freebie because it's just a reference count that it got to return by, and we don't have to do all this copying of big data structures around. So I think that's all I have. Yeah, thanks. Cool.